This is question number 6. If you look at the diagram, we have two pistons in the diagram, piston number 1, P1, and piston number 2, P2, which are frictionless pistons. And at the same time, you may hold those pistons and pull them out or push them down. There is a third piston or a valve where gas can be added. According to Boyle's law, when N and T are constant, P times V is a constant value. So according to Boyle's law, let's look at number 1, number 2, and number 3, whether P times V will stay constant or will change. Our purpose is to find in which of these cases P times V will change. In number 1, it says N, number of moles, and P2, piston 2, are held constant, piston 1 is pushed down. If piston 1 is pushed down, that means pressure will increase and volume will decrease. In that case, P times V will be constant. So, it will not change. In question number 2, P1 is held in its place, P2 is left free to move, and a certain amount of gas is added. Because N is increasing, P times V will increase. It will not stay constant, so number 2 will make a change in the P times V value. In number 3, pistons P1 and P2 are held in their places and some gas is added. If some gas is added to the container, number of moles will increase. Due to that, pistons are held in their places, so pressure will increase and P times V will increase. So it will make a change in the P times V value. The answer is 2 and 3. This is question number 2 in worksheet number 2. We have a container with a frictionless piston. And the frictionless piston is staying at this position because the pressure of the atmosphere, PO, is equal to the pressure of the gas X inside. Which of the following will double if the piston is pushed to position K at constant temperature? When you make the piston push, or when you push the piston to position K, it means you're making the volume smaller and the pressure is going to increase. So P times V is going to stay constant. So number 3 is definitely going to stay the same. It's not going to double. What about number of particles in unit volume? When you make the volume 1/2, the number of particles that are present in unit volume is going to double. So this is going to be correct. Again, when you make the volume 1/2, the mass is not changing, so density is going to double. So number 2 is correct.